Dear children, today we will start our class 11 syllabus. In physics, we will start vector. First one is your vector analysis. First, we will know what do you mean by scalar quantities? What do you mean by vector quantities? First, scalar quantities. What do you mean by scalar quantities? The quantities which have only magnitude but no direction are called as scalar quantities. Means, if you take the example of distance that has only magnitude but no direction. If you take speed that has only magnitude but no direction. Similarly, if you take displacement, it has both magnitude as well as direction. So displacement is not a scalar quantity. So the quantities which have only magnitude but no direction are called as scalar quantities. Example: distance, speed, work, power, energy, time, etc. So now come to vector quantities. Vector quantities, these are the quantities which have both magnitude, direction, and another point is that which obey the laws of vector addition. Means the quantities which have both magnitude, direction, and obey the laws of vector addition are called as vector quantities. Example: displacement, velocity, acceleration, force, etc. Then why the law of vector addition is needed here? Because if you take electric current has both magnitude and direction, but it doesn't obey the law of vector addition. What is law of vector addition? We will discuss later, but now you remember the quantities which do not obey the laws of vector addition cannot be considered as vector quantities. So as electric current doesn't obey the laws of vector addition, so electric current cannot be considered as vector quantity. Electric current is considered as scalar quantity. So now come to, if a vector quantity has both magnitude as well as direction, then how do we represent vector quantity? Representation of a vector quantity. Representation of a vector quantity. Just you learned here a vector quantity which has both magnitude as well as direction. So a vector quantity has both magnitude as well as direction. So we have to represent a vector quantity, means we have to represent its magnitude as well as direction. Let it be, it is a vector. So you remember, a vector quantity is represented by a line with an arrow over it. Then which gives you the magnitude, which gives you the direction. So you remember, the length of the line gives you the magnitude of the vector quantity, and this arrowhead gives you the direction of vector quantity. Suppose these are the two vectors, it is A vector, it is B vector. So From this representation, tell me which has more magnitude and what do you say about the directions. Here you see B vector is represented by a line of greater length, so definitely the magnitude of B is greater. And you see both A vector and B vector are acting towards right, so their directions are same. If I put the arrowhead at here, then what do you say about their magnitudes and directions? Definitely the magnitude of B is greater because length of the vector is more, that is more. And what's about the direction? A is directed towards right and B is directed towards left. So their directions are opposite. So now come to types of vectors. Types of vectors. First one is your equal vectors. What do you mean by equal vectors? Two vectors are said to be equal if they have same magnitude and same direction. How do we represent them? It is suppose A vector, it is suppose B vector. You see the length of line A vector represented by A vector, that is this line length and this line length is same. So the magnitude of A vector and B vector are same. What's about the direction? You see A vector is directed towards right and B vector is directed towards right. That means the directions also same. So here I can say A vector is equal to B vector. So now come to negative vector. So you remember, if two vectors are acting along same direction, then you can say the angle between A vector and B vector is 0 degree. If two vectors are acting along opposite direction, then you can say the angle between A vector and B vector is 180 degree. You see, it is suppose A vector, it is suppose B vector. So you know the geometry, what is the angle between A vector and B vector? That is 0 degree. If it is A vector and it is B vector, now you tell me what is the angle between A vector and B vector? That is 180 degree. So you remember, same direction means two vectors acting along same direction means the angle between them is 0 degree. Opposite directions means the angle between the two vectors is 180 degree. So now come to negative vectors. So what do we mean by negative vector? So one vector is negative of another if they have same magnitude but opposite direction. So you see, it is suppose A vector, it is suppose B vector. You see here, the length of this line is same as length of this line. That means here magnitude of A vector and B vector are same. And what's about direction? A vector is directed towards right and B vector is directed towards left. That means the angle between A vector and B vector is 180 degree, or you can say directions are opposite. So here we can write B vector is equal to minus A vector, or you can write A vector is equal to minus B vector. So now come to collinear vectors. Collinear. So you see, co means common, linear means line. Two vectors are said to be collinear if they act along same line, common line, or along parallel lines. You see, it is suppose A vector. If B vector acts along this line, or if B vector acts along the parallel lines, let it be C vector. So you see here A vector acts along this line, B vector acts along this line, same line. So here you can say A vector and B vector are called as collinear. Then what's about C? Here you see C vector acts along this line, means parallel to this one. That means here also you can say C vector is collinear to A vector, or you can say here A, B, C are collinear to each other. What's about the direction? If you here I have put direction same, that is towards right. If I will put here direction towards left, then what happens? You see, the line of action of A and C are parallel to each other. Then the direction is immaterial, means direction that may be same or may not be same. But if line of action is same or parallel, then the vectors are said to be collinear. Now come to types of collinear vectors. You remember, collinear vectors are of two types. One is your parallel vectors. Parallel vectors means vectors are said to be parallel if they have same direction. Suppose it is A vector and it is B vector. You see, A vector is acting towards right, B vector is acting towards right. Here you can say A vector and B vector are parallel to each other. Then the magnitude, whatever the magnitude may be. Condition is that if two vectors are acting along same direction, or you can say if the angle between the two vectors if 0 degree, then the two vectors are said to be parallel. So here question arises, when two parallel vectors become equal with each other. Definitely parallel vectors means already they have the same direction. If their magnitudes will be same, then two parallel vectors become equal with each other. So now come to, you remember the angle between two parallel vectors is 0 degree. So now come to anti-parallel vectors. Anti-parallel vectors. You remember, two vectors are said to be anti-parallel if they act along opposite directions. Suppose it is A vector, it is B vector. Now you see the directions are opposite to each other. Now you can say A vector and B vector are anti-parallel with each other. Now what is the angle between them? Here you see A vector and B vector are in opposite direction. So opposite direction means the angle between them is 180 degree. When two anti-parallel vectors become negative of one another, you see, negative vector means equal magnitude opposite direction. Already you see they have the opposite direction. Then if they have equal magnitudes, then you can say these two vectors are negative of one another. So now come to co-initial vector. Initial vectors. So what is co-initial vectors? You see, it consists of two words. One is your co, then initial means common, co for common, initial starting means vectors are said to be co-initial vectors if they have same starting point or common starting point, whatever their magnitudes or directions may be. It is like A vector, let it be B vector, C vector, D vector. Whatever their magnitudes or directions, that doesn't matter. If their starting point is same, then you can say these vectors are said to be co-initial vectors. Similarly, coterminous vectors, if they have common terminal points, means common end points. You see, let it be A vector, it is B vector, it is C vector. Now you can say A vector, B vector and C vector are coterminous vectors. So now come to coplanar vectors. Coplanar vectors, you see, co then planar means co means common, planar means plane. Vectors are said to be coplanar if they act along same plane or they lie in the same plane. Suppose it is x-axis, it is y-axis. If vectors are lying in the same plane, then you can say they are coplanar vectors, irrespective their magnitudes and directions. But condition is that they must lie in the same plane. So now come to localized vector or fixed vector. You remember, localized vector means having fixed initial point. A vector is said to be localized if its initial point is fixed. So, in other words, I can say, if it is a vector, if I will shift this vector, if the effect will change, then you can say it is localized vector. Means, if localized vector, if it shifts its line of action, then the effect will be changed. Force is a localized vector. It is a body. If you apply force along this direction, like this, if the line of action is like this, if the center of mass of the body lies on the line of action of the force, then it makes translational motion. If you apply force like this, then the body rotates. That means effect changes. So the force, you can say it is a localized vector or fixed vector. Next is your non-localized or free vectors. If initial point is not fixed, initial point is not fixed. Initial point is not fixed means, suppose it is a vector, let it be a vector. If you shift the vector like this, along the parallel line, or if you change the line of action of the force, not force, the line of action of the vector, then if the effect will not change, then it is called as non-localized vector or free vector. For example, velocity, displacement, these are non-localized vectors or free vectors.